Hi folks, today we're going to look at graphing in Excel. I'm using Office 2016 for PC, so if you are on Mac or have a later or more recent version, your buttons may be placed a little differently, but all the features that we're looking at today should be present in your version. It just may take a little digging around for you to find them. If you end up in trouble, the best thing to do is hop on over to your favorite search engine, just type in how to do whatever in Excel, whatever your version is, and you'll find a bunch of tutorials walking you through exactly what you want to do. Once you've mastered the art of searching for things and following instructions, there's really nothing you can't do. That applies to more than just Excel. Anyhow, let's take a look today. So here you can see in front of us a spreadsheet with a bit of data, and what we're actually plotting today is the percentage of guanine and cytosine base pairs in a piece of DNA versus the melting temperature of that piece of DNA. In other words, the temperature at which the two strands of the DNA will separate. So we've got some data here, and we want to see, is there some relationship here, and what is it? So if we've got data and we're not sure what the relationship is, and we just kind of want to take a look at the plot, the best form of graph for us is going to be a scatter plot. So what we're going to do is we're just going to highlight all of the data by clicking and dragging. Then we're going to go up to Insert at the top, and then we're going to go over to our charts. And here we've got a lot of different options. Maybe you recognize a bar graph, a pie chart, and if you were to click on these, you could see that it would give you a little preview of different ways of plotting this data. But we want a scatter plot, and that looks like this. And so we just want a plain scatter plot, and that's what this one is right here. And there are other options here that might be appropriate for other kinds of graphs, but for us, we just want a plain old scatter plot. So we're going to click on that, and ta-da, here's our graph. But there's a bunch of stuff that we are going to want to do with this. So first of all, you might notice we're missing axis titles, so our readers are not going to have any idea what this graph is about because there's no titles, there's no axis titles. It's a real mess at this point. We'd also like to know mathematically what the relationship is between the percent of guanine and cytosine and the melting temperature are. So it would be great if we could do a little mathematical analysis and find what in this case looks very appropriate would be a linear equation for this data. So the easiest way to do that in this version of the software is just to click on your graph. It'll bring you to Chart Tools, Design, and you can do a lot of these things, adding axis titles and so on, using these quick layout tools. So they know that most of the time you're going to want to do a certain number of things. So in this case, we want to add axis titles, and we want to do a best fit line on our data. We can do all of that at once with this little function down here. You can see it says f of x right there on the chart, showing us that it's going to be putting a function in. So you can hover over these and you can pick the one that best suits your needs and does what you need it to do. Or I'll show you in a minute how you can add and subtract these features one by one to get exactly what you want. But for me, a graph that has axis titles and a trend line looks pretty good. So I'm just going to click that. Now I've got a lot that I want, a little bit that I don't want, and a little bit of modifying to do. First of all, I don't need this legend over here. That's not doing anything for me. Titles, we're going to actually title in the document that we input the graph into, so I'm going to delete the title. This trend line here, the equation for the line, is great, but it's not super easy to read, so I want to make this a little bigger and make it stand out a bit more. So the first thing I'm going to do is increase the font size a bit. I think that's good. And then I want this box to stand out a bit, so in order to do that, I'm going to click on the box. I'm going to right click, and I'm going to select an outline, and I'm going to select a fill. So I've filled it with the color white, I've outlined it with the color black, and now I've got a little box that stands on its own and shows me the information for this relationship. All right, now I need to title my axes. So my horizontal axis here is the %GC, and my vertical axis is going to be the melting temperature, T sub M, and this is in degrees Celsius, so we'll put those units in. Whenever you have units, put them on your axes so your reader knows exactly what it is they're looking at. And there you have it, a pretty nice little graph. If you wanted to go in and make it a little prettier, if you wanted to bold stuff or anything like that, that's totally fine. Just remember the key goal for graphing is to communicate this information represented by this graph as clearly as possible to your reader or your viewer. Okay, so if you want to jazz it up a little bit, that's fine. Just remember, clarity comes first. All right, so now I'm going to take this graph. Let's say I'm writing up a report in Word. I can just select this graph. I can do a Control C to collect it, or Apple C if you're using a Mac, or I can right click and click copy. Then I can come over to Word. I can paste that right in. And there's my graph exactly as I had it before. And you can even, in Word, edit some of these things if you want to. You don't have all of the tools that you had in Excel to play with it, but you do have some of them. So if you need to do a little editing, you can do that here. So now we can put our title in here. We go down to the bottom. We always label graphs or figures at the bottom. Remember, figure floor, tabletop. We're going to do a bold text here, figure 1, period, and then the title. And here I'm going to call this dependence of DNA melting temperature on GC content in 100 millimolar NaCl, which is the solution that this data was prepared from. All right, so there's my graph, there's my title, everything is nice and crisp and clear. It's very easy for people to read. And by the way, I can resize this in Word if I would like it to be a little bigger, take up the full page. Great. All right, let's take a look at the next type of graph. All right, we're back, and here we're going to take a look at another data set. We're going to start just the same way. Here we've got data that is showing the optical density of an E. coli culture over time. So this is basically a measurement of how cloudy the culture is as time goes on, and that's a proxy measurement for how much bacteria there is growing in that solution. The higher the OD, or optical density, the more stuff there is floating around. In this case, it's the bacteria. So we're going to go back to Insert. We're going to pick a scatter plot exactly as we did before. And here we can see we've got a shape that is very different from the straight line that we had in the last data set. So adding a linear fit here wouldn't make a lot of sense. Let's add some layout here. Here I'm going to pick this one, which doesn't add a linear fit, but does add some axis titles and some other things. I'm going to delete the legend as I did before. I'm going to delete the title as I did before. And I'm going to edit my axis titles. This is going to be the time in hours. And this is going to be the optical density, which I'll just abbreviate as OD. And we can say it's the OD 600, in fact, because that's measured at 600 nanometers. So that's not quite our units. In fact, it's not our units, but it's a piece of information that our readers are going to need. Now, how can I get a line that describes this? Well, there's a couple different ways. We can do it mathematically, and I'll show you that, or we can draw it by hand. I'll show you that as well. So if we want to do it mathematically, and we're looking to see, is there actually a mathematical function that we could use to predict things like bacterial growth? Well, we can take this data, just click on a point, and it will highlight the data, and then you can right-click and go to Add Trend Line. And a little thing will come up over here, and it'll say, okay, well, what kind of trend line do you want? And as you click through these, you'll see it kind of map out here, and you can see how well does it fit. So that's a linear fit, didn't really work. Exponential fit, didn't really work. Here's a logarithmic fit, and that's a pretty decent fit there. A polynomial fit, and you can change the order of the polynomial and play with that if you want. You could try powers. You could do a moving average, though that's not really that wouldn't really be finding an equation. That would just be another way of representing the data. These are all options. And if you wanted to use one of these, let's say we're going to call this a third order polynomial, then you can show the equation and the R value, which is a measure of the correlation, or the measure of the fit, by clicking those little buttons right there. So that's an option. You can use that. I think it implies something sometimes that we might not be eager to do. So is this really the relationship between the amount of time and the optical density? Like, is that a model that we're trying to propose, or are we just trying to show a general trend? If we're just trying to show a general trend, then maybe we should keep it a little simpler, and rather than trying to fit a function to our data, maybe just draw a line. So I'm going to go to Insert, and then I want to insert a shape, and shapes are under illustrations. If your thing is more expanded than mine is, you probably see that button already. But here I go to Shapes, and I'm just going to go to the freeform drawing tool, which they call Scribble. So we'll select this, and now I can just draw in the shape of the curve as I see it. I'm going to go with the kind of elongated S shape, something like that. And now over here, I can format the shape. I can make it a little thicker. I think that's good. Maybe I want to change the color so it stands out from the data points a little bit better. We could make it really stand out with a nice orange tone, right? Whatever you want to do. Remember, clarity is the name of the game. And then when you click out of that, you'll see that there is your line sort of denoting the trend. All right. So this is a way that you can have a trend line of sorts. You can either use the curve fitting mathematical approach, or you can just hand draw it in. It's really up to you with a data set that is not linear. All right. Now let's take a look at the final item for today, which is going to be graphing two data sets on the same graph. All right, so here we are again, and we've got the same data as before, but we've got another data set. So it turns out that the data we collected for that first graph was bacterial growth at 37 degrees Celsius, body temperature. Now I've got another data set, which is going to be bacterial growth at 22 degrees Celsius. That's about room temperature, about 70 degrees Fahrenheit. Now, what if we want to graph both of these on the same graph so that we can compare those data sets in one place? Well, again, it's pretty simple. We're going to highlight the whole data set, titles and all. We're going to go insert. We're going to go to scatterplot. We're going to insert the scatterplot. And there's our two data sets. Okay? So it'll even tell us here, and this is a nice legend, I think, for our purposes, 22 degrees Celsius OD is in orange and 37 is in blue. Now, again, we're going to want axis titles and things like that. So I'm going to pick this first one again. This is going to be the time in hours. This is going to be the optical density, 600 nanometers. Now, once again, if I want to show the trend lines, I can go over here, right-click, add trend line, or if I want to draw them by hand, which I'll do this time, then I can go to Insert, Illustrations, Shapes, Freeform Scribble, and we'll just draw two lines in here. One for the blue data set. There it is. And I'll make it a little thicker. I'll keep that one blue. And then one for the orange data set. Something like that. And this one I'll make orange to match that data. I'll make it the same thickness. And there we go. All right, so you make these lines as pretty as you can. There's some other drawing tools, curve tools, things like that if you want to play with those as well. I'll show you one of those now. So let's say I'm not too confident in my line drawing skills and I want to try something a little different. So I'll go to Insert, Illustrations, Shapes, and I'll pick the curve tool instead. So now I basically can just click a bunch of points along my curve, and then when I'm done, I hit Enter, and it'll make a nice smooth curve for me. Okay, so I'll make that 0.2 and orange again. So this is another way of doing this. You're going to get a little bit of a smoother line if you use the curve tool than if you use the freeform tool. All right, so these are options that you have. Play with them and do what makes sense for you. And remember that the goal overall is clear communication to your reader or your audience. All right, so I hope this was helpful. Let me remind you here at the end of the video that if you ever run into any software problems for any popular software at all, the best thing to do is go to your search engine of choice, type in how to do this in this software, include the version, and then you're going to find tons of people who had the same problem and tons of people helping them and giving step-by-step options on how to solve the problem. So if you can master that skill of searching things and acting on the results, you are going to vastly expand your ability to use not only software, but also fix stuff, solve problems, you name it, any skill on the planet that people do with regularity, you can find out how to do it better with a quick search and following up on the results. All right, folks. Well, I hope that this was helpful for you. We'll see you next time. Bye for now.